everybody, this is Ms. Bufford, and in this video we're going to talk about dimensional analysis and the metric system. So your learning goals for this video are to understand the metric system and why it's important in science, and to be able to perform conversions using dimensional analysis. So why is the metric system important? So this system came about because of the need to standardize the way things were measured, and it allows scientists from all over the world to be able to communicate results more efficiently and to more easily be able to compare data. So it's really important in science. Some characteristics that this system has that make it really easy to use are the fact that it uses base 10 just like our numbering system. So each prefix that we're going to talk about is 10 times larger than the prefix or 10 times smaller than the prefix that came before or after it. There is one unit for each physical quantity that can be measured. And those prefixes that I mentioned a minute ago are used to scale units up or down. And then unit conversions are really easy. They can be performed just by moving a decimal point. In the United States, we still use the empirical system of measure. This system is not based on any universal standards, which makes it more difficult to use, and its equivalencies are not exact. And we still use this system here in the United States because change is hard. All right, so the metric system has what are called base units. And these are those basic units of measure for each different thing that can be measured. And those are mass, which is measured in grams, distance, which is measured in meters, time, which is measured in seconds, temperature in Kelvin, the amount of a substance is measured in moles, the electric current is measured in amperes, and luminous intensity is measured in candelas. So these are all just the basic measurements that we can take. And if we sometimes need to use combinations of these to describe other physical characteristics of other things, for example, area, speed, density, acceleration, and volume. And in particular, we use density and volume here in chemistry. Density is just the mass divided by the volume of something, and it tells us a little something about how tightly packed those particles are. And every substance will have its own unique density. And then volume, that just tells us how much space something is taking up. And we can find that by multiplying the length times the width times the height. And because of that, let's take a look at an example of something that we're actually going to see quite a bit in here. We have liters. A liter is actually a decimeter cubed. And a milliliter, which is something else we're going to use a lot in chemistry, is a centimeter cubed. And if you like to watch a lot of the doctor shows on TV and you hear the doctors calling for, 30 cc's of something, then a cc is a cubic centimeter. This is this right here. And it's a milliliter. So really they're just saying, I need 30 milliliters of something. But cc's just sound so much cooler. All right, so now we're going to focus more back on those base units that we talked about. If we take a look over here, at this table, you'll notice I have base units right here in red in the middle. And then anything that's listed up above that is units that are larger than one base unit. And then anything below that are units that are smaller than one base unit. Okay, or prefixes that describe those units. So, for example, let's say I have just 1 gram of something. That would just be I have 1 gram is just one single base unit. Right? But if I had a decagram, that would mean that I had 10 grams, or a hectogram. A single hectogram is 100 grams. A kilogram is 1,000 grams, or 1,000 base units. A megagram would be 1 million grams, and a gigagram would be 1 billion grams. All right? And that could be for any base unit. It could be, if we're doing this in meters, we could have a decameter would be 10 meters, and so on. And then towards the bottom half of this chart, you'll see things get smaller. So If I had 1/10 of a gram, then I would have a decigram. So if I took one base unit and I divided it by 10, I'd have a decigram. If I had a centigram, I would have 1/100th of a gram. A milligram would be 1,000th of a gram. A microgram would be 1/1,000,000th. That's a lot of zeros, of a gram. And a nanogram would be 1/1000,000th of a gram. That means I took 1 gram and I divided it into 1 billion little pieces, and one of those little pieces is 1 nanogram. All right, so it's really tiny. So this is, how the units for the metric system are organized. All right, so let's go ahead and talk about how to convert between units in the metric system. Like I said before, there are really easy ways of converting units in the metric system. It's basically you can move a decimal place, but we're not going to learn that in this video because we're focusing on learning something called dimensional analysis here. And it's a unit conversion technique that allows you to keep track of units. So, for example, let's go ahead and take a look at this problem. We know from the table on the previous slide that there are 1,000 meters in a kilometer. And if we wanted to know how many meters were in 35 kilometers, what would we do? So here's the information I have right here. I have 1,000 meters equals 1 kilometer. How many meters are going to be equal to 35 kilometers? And if you're looking at this, it seems pretty intuitive. Hopefully you can look at this and you would say, I'm going to multiply 1,000 by 35, and that'll tell me exactly how many meters I'm going to have. And if you say that and you think that, you're absolutely correct. So we do want to multiply these numbers. But if we're just straight up multiplying them and we're not looking at what the units are doing, then you might accidentally write this for your units. Because in math, when we're dealing with numbers that have units, we have to treat the units the same way we treat the numbers. So we're multiplying the units here. And it doesn't make sense to have meters times kilometers. They're both the same units or base unit, just one is an order of magnitude or several orders of magnitude larger than the other. And it just doesn't make sense to have that as our units, especially when the goal here is to convert from kilometers to meters. So I'm going to put an X on that because that's not right. And dimensional analysis, let's talk about that. Or sometimes you'll hear this called the factor label method, allows us to easily see what is happening with units. And we're learning these simple conversions now in preparation for something that we're going to be doing next semester called stoichiometry. And learning these conversions and learning how to do dimensional analysis makes stoichiometry a lot easier later if you already are familiar with how to cancel these units out using this method. So if you know how to do the conversions, the way we talked about it up above, that's awesome, but you really need to learn how to set these up so that the units cancel out, because later units are really, really important. Well, they're always important, but this will help make your life easier later. All right, so let's talk about it like this. In math class, when you multiply fractions, when you have the same number in the numerator of one fraction and the denominator of another fraction, what happens to that number? So here's our two fractions here, and you can see I've got a 2 in the numerator here and a 2 in the denominator here, and I'm multiplying these fractions. So what happens in a case like that? It cancels out. So this 2 and this 2, they cancel each other out, and we can clearly see the answer here is going to be 2. Okay? So when we're dealing with units, remember we treat them the same way we treat numbers. So if we have the same unit on the top and the same unit on the bottom of another fraction, then they're going to cancel each other out. And that's what we're looking for. So let's take a look at that same problem from here, now down here at the bottom. So I have 35 kilometers. I want to multiply that by 1,000 because I know that that's going to tell me how many meters I have. But how does that work? Like, why does that work the way it does? Well, if I use this information, this equivalent statement that I wrote, 1,000 meters is equal to 1 kilometer, I can set the problem up so that kilometers cancels each other out, and it shows you visually what happens to those units, and you're left with meters. Okay, so those are going to cancel out. But the big question here is, what is this? What is this fraction that just showed up? Why did I write this equivalent statement as a fraction down here? So let's talk about that next. So what is a conversion factor? A conversion factor is a ratio or a fraction that is equal to 1. And this just means that the numerator and the denominator, they're equal in value, but they're expressed in different units. All right, so for example, our 1,000 meters is equal to 1 kilometer, or there are 1,000 meters in 1 kilometer, and we can write that as this equivalent statement right here. All right, and any equivalent statement that we can write can be written as two different conversion factors. There's two ways you can do it. Okay, so here are the two ways we can write this conversion factor here. We can write it with 1,000 meters on top and 1 kilometer on the bottom, or we can flip it and write it like that. These are equally valid, right? They're both equal to 1, and they're just equally valid. Depending on the problem you're working on, though, one is going to be better for you in a certain situation than another. And we're going to talk about how to choose your conversion factors later, but let's go ahead and focus on how to write the conversion factors and make sure that we can just do that. All right, so I want you to go ahead and pause the video and write both conversion factors that can be written for all of these equivalent statements. All right, so hopefully you were able to get these. So for this first one right here, for number 1, I can write both conversion factors like this. I can have 10 meters on top and 1 decameter on bottom, or I can have 1 decameter on top and 10 meters on the bottom. They're both equally valid. Then for number 2, I got this, 1,000 milliliters on top, 1 liter on bottom, 1 liter on top, 1,000 milliliters on bottom. And remember, all of these are equal to 1 because the value on the top and the bottom is the same. They're just expressed in different units. Number 3 is right here. Number 4 is right here. And there's number 5. Okay, so now let's go ahead and talk about how to use conversion factors to convert between units. All right, so our problem says it wants us to convert 250 milligrams to grams. So I'm trying to get from milligrams to grams, all right? And to start this problem, I need to start with the number that's given to me in the problem, which in this case is 250 milligrams. So I'm going to go ahead and write 250 milligrams. All right, and I'm just going to go ahead and write that over 1. Writing it over 1 doesn't change anything about it. It's still equal to 250 milligrams. But I'm doing that because I'm going to start multiplying by my conversion factors, which are written as fractions too. And this just kind of helps keep you straight on what's on top and what's on bottom. Okay, so our next step is, I'm going to go ahead and write that again. All right, our next step is to determine which conversion factors will be useful to help cancel out unwanted units and leave behind our desired units. All right, so which conversion factors are going to be useful to us in this conversion? Like we said, we're trying to convert from milligrams to grams. And so what we would want to do, the ideal situation here, is to find an equivalent statement that has both milligrams and grams in it. So I'm going to take a look at this little table of equivalent statements that I have over here. And you'll have something very similar to this in your OneNote notebook that you're going to want to use. And so let's take a look. Here we go. I've got 1 gram is equal to 1,000 milligrams right here. This is the exact one that I would like to use. And now I need to write some conversion factors so that I can choose the best one to solve this problem. And so what I'm going to do is I'm going to write 1 gram over 1,000 milligrams, or 1,000 milligrams over 1 gram. Which one of these am I going to be able to use to cancel out milligrams? So remember, I'm multiplying it by that fraction, by that conversion factor. And remember, I want milligrams to cancel out. So hopefully you said this conversion factor right here. And so I've got 1 gram over 1,000 milligrams. Okay? So then milligrams cancels out. And then the last step, which I'm going to erase all my progress here if I do this. The last step is to solve by multiplying or dividing. All right? In this case, when we're doing these problems, we can ignore any number that's 1 because 1 is not going to change the value of our answer. So I'm going to take 250 and I'm going to divide it by 1,000 because this is on the bottom. And I end up with, if I divide that by 1,000, 0.25 grams. All right, so here is my problem again. There you go. There's the last step. All right. So let's go ahead and talk for just a minute about significant digits. We learned all about sig figs and how to multiply and divide and all that stuff with significant digits in an earlier building block. And now we need to talk about how we're going to report significant digits in the answers for these conversions when we're multiplying and dividing these numbers. And we're using all these conversion factors. So we want to remember that significant digits are only relevant for numbers that represent measurements, first of all. Second of all, if the conversion factors that we're using in our problem are metric conversion factors, they are exactly equivalent. So, 1,000 kilometers is equal to 1 meter. 1,000 meters is equal to 1 kilometer. Those are exactly equivalent to one another. And so they're considered to have an infinite number of significant digits. And so they're not going to limit the number of digits that we can report in our answer. That's going to be limited by other numbers in that problem. However, conversion factors that contain English units, they contain some uncertainty because those equivalents are not always exact. And so when you're using conversion factors that contain English units, you want to be really careful to make sure that your conversion factor is not limiting your answer. But I'm going to go ahead and make things really easy for you. And in this class, all year, we're not going to worry about any conversion factors limiting our answer. So what we're going to do is the number that you start the problem with, however many significant digits that has, you're going to put that same. You're going to report your answer with that same number of significant figures. Okay. So with that being said, let's go ahead and do some examples. All right. So I want you to go ahead and pause the video and convert 450 centimeters to meters. And you have this conversion chart or these equivalent statements over here to use to see if you can write some conversion factors. All right, so now let's take a look and see how you did. There we go. We started our problem with the number from the problem. And we're converting here from centimeters to meters. So we're going to look over here. Oh, and it's our first one right here. Here's our equivalent statement. There's centimeters and meters. And so I'm going to set that up right here. And I want to make sure that I set it up so centimeters cancels out. And then it leaves me with units of meters, and I've got my final answer. All right, go ahead and pause the video again and give the second one a shot. All right, so now we're converting 2 grams to milligrams. So grams to milligrams. And let's make sure, let's see if we have a conversion over here. Yep, I've got grams to milligrams. So 1 gram is equal to 1,000 milligrams. And there we go. I've got 2 grams, and I'm using that 1 gram equals 1,000 milligrams to convert this. So I'm canceling out my grams. Now I'm in milligrams, and there's my answer. Okay, so now let's try something that's a little bit more difficult. I want to be converting 5,000 milliseconds to kiloseconds. And so in this case, we're going from something that's really small to a unit that represents something that's really large. And when we do this, the easiest way to do this when we're not just moving the decimal around is to first convert to your base unit. And our base units here are seconds. So seconds is my base unit. And I'm going to first convert from milliseconds to seconds, and then I'm going to convert from seconds to kiloseconds. That just makes it really easy. You don't have to think about how many decimal places they are away from each other. You can just do this straight up conversion from, to the base unit and then to the unit that you're trying to get to. All right, so let's go ahead and we're going to start with the number in the problem. So there's our 5,000 milliseconds. And milli means 1,000. So we know that there are 1,000 milliseconds in 1 second. And I'm going to set that up so that milliseconds cancels out. And now I'm in seconds. And I know that kilo means 1,000. So I know that there have to be 1,000 seconds in a kilosecond. And I set that up so that seconds cancels out. And now I've finally made it to kiloseconds. Okay, so there's my unit. And I'm going to go ahead and plug this into my calculator. When I do that, I'm going to plug in 5,000 divided by 1,000. And I'm dividing here because it's on the bottom of this fraction. Okay, and then I would hit enter, and then I'd hit divided by again 1,000 since it's on the bottom. And then I'd hit enter. And there I go, 0.005 kiloseconds. All right, so let's go ahead and do a couple example problems. So you go ahead and pause the video and see if you can convert 3,500 micrometers to kilometers. Remember that micro means million or millionth, and kilo means 1,000. All right, so here's our answer. We started with the number from the problem, and I know that micro means millionth or millionth, yeah. And so I know that there are 1 million micrometers in 1 meter, and I set that up so micrometers cancels out. And then I need to convert from meters to kilometers. And I know that there are 1,000 meters in 1 kilometer because kilo means 1,000. And so I'm going to cancel out meters. And there we go. I'm not sure why kilometers is canceled out here. It shouldn't be. It's circled. And so my final unit is kilometers. Here's this really teeny tiny number. And it's so small that we really need to put it in scientific notation. All right, and remember, small numbers are associated with those negative exponents there. All right, so go ahead and pause the video again and convert 0.0532 megameters to micrometers. Remember, mega means billion, and micro means, mega means million, and micro means millionth. All right, here's our answer. So I started with the number in the problem, and I know that there are 1 million meters in a megameter. So I'm going to set that up so megameters cancels out. And then I also know that there are 1 million micrometers in 1 meter, and I set that up so that meters will cancel out. And I end up with this huge number right here, which makes sense because this was a really big unit, and now we're using really tiny units to describe the same quantity, so the number is going to be a lot larger. And remember that large numbers are always associated with those positive exponents when we write this in scientific notation. And there we go. All right, so we can use dimensional analysis to convert between all kinds of different units. It doesn't have to be units in the metric system. It's really handy, especially for when we have units that are metric and empirical mixes. So we've got, the inch is equal to 2.54 centimeters. We can use it for any kind of conversion, anything where you're canceling out units. So here's just a table of some of those equivalency statements. And I hope this video was helpful. If you have any questions, you're welcome to save them and ask them during class, or you're welcome to contact me through email or It's Learning. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.